In today's busy world, we tend to take technology for granted, and nowhere can this be seen more than in how people use their cell phones. Whether it's calling, texting, tapping, streaming, buzzing, or chiming, our phones have a complex makeup that allows them to carry out their many functions. Neodymium is a heavy element that is part of this complex makeup. In order to understand our phones on a deeper level, we are going to learn how neodymium formed, where neodymium came from, and what neodymium is used for specifically. The story begins several billion years after the Big Bang, the origin of the universe. When stars of extreme mass came to the end of their lives, they exploded in what's called a supernova. A supernova releases matter out into space and begins the formation of many elements that we are familiar with today. In this matter from the supernova, atoms undergo many changes, including a neutron turning into a proton and releasing an electron, forming the first isotope of neodymium. A rapid bombardment of neutrons on this atom results in the formation of several stable isotopes of neodymium through this process of neutron capture. An isotope is considered stable when the nucleus no longer decays into a different element, as opposed to an unstable and radioactive element that will decay until it reaches a stable form. You can think of a stable isotope as being a happy atom that does not want to change because it likes the way it is. So we know how neodymium came to be, but how did it get to Earth? Around 4.6 billion years ago, a huge rotating cloud of dust and gas, known as a protoplanetary disk, formed in our galaxy. This protoplanetary disk also contained heavy elements, including neodymium, that rotated and eventually built up to form the terrestrial planets we know today, including our home, Earth. After its formation, Earth began the process of planetary differentiation based on the density of the minerals in its makeup. Dense elements that tend to form iron alloys sank down to make up the core, and the remaining elements stayed in the mantle. The crust formed when elements in the mantle melted slightly due to temperature and pressure changes inside the Earth. Neodymium is one of these elements, and thus is preferentially incorporated into the makeup of the continental crust. Now that we understand how neodymium got on our planet, we can look at where it is found on Earth. Neodymium is mostly mined from rocks like phosphates and carbonates. The dominant global extractor of neodymium is China, with other significant deposits being located in Australia, Brazil, and the western United States. Therefore, most mines for neodymium are in these countries. The United States is home to the Mountain Pass mine in California, which is the only significant rare earth element mine in North America, hosting a large extraction site for neodymium. Most mining of neodymium is done in large open-pit mines. The mining process is followed by treatments such as crushing, leaching, solvent extraction, and precipitation to separate out the neodymium from other substances. Less commonly, neodymium can be taken from secondary sources like coal ash and mining or electronic waste caused by anthropogenic activity. It is important to stop and recognize that the mining of rare earth metals, such as neodymium, is linked to severe human rights abuses and crimes in other parts of the world. In northern Myanmar, the Kachin state has multiple sites for mining neodymium and have had many reported cases of human rights abuses. These crimes were significantly exacerbated by Myanmar's political coup in 2021, as a state with an unstable government has little power to limit corruption and protect workers' rights. States with weak governments tend to have mining sites, as there are fewer regulations, resulting in cheaper and easier extraction at the cost of human life. The effects of neodymium mines in these communities goes beyond just the miners and can lead to displacement, pollution, negative health impacts, and the bolstered support of the oppressive military regime in the case of Myanmar. Finally, now that we know how scientists extract neodymium, we can dive into what neodymium's role in the makeup of the smartphones that we rely on every day is. In phones, neodymium bonds with iron and boron to form a magnet that is behind powering cell phone features such as audio speakers, microphones, and vibrations. It is possible for neodymium to be recycled after its use in manufacturing smartphones, but this is currently very rare. Highly complicated processes are required to effectively extract the neodymium and any other rare earth metals from electronic waste once it has been used. Now, you hopefully know a little bit more about the element neodymium and how it helps your phone work. By understanding where elements come from and how they came to be in our world today, we can better understand the technologies we create and use.